So I'm walking the rails, and I'm thinking about infrastructure and how gabions can be used in civil infrastructure, because Dave and I have been fans of gabions for a while. They're really a good solid way to make strong structures that hold back mountains from eroding, and you can build domiciles and shops and stuff out of it. You can make decorative walls. You can do all kinds of crazy stuff with gabions. And rail has been arguably a very effective tool if you ignore the politics of how it got into place. One of the things that happened in American history is people were encouraged at a certain point to expand out, to increase the 15 states to more states by occupying territory and calling those territories a very soft term for, well, we got dibs, but we haven't cemented in the deal. And then obtaining the use of formal agreements, constitutions, and statehood. And in this process, had to move a lot of stuff. These are Western European industrialists, right at the beginning of the industrial age in Western Europe. They came up with this idea, spread it all over the world, and it moves a massive amount of freight for a very low price in man hours and fuel. The infrastructure is pretty easy to put together in general terms, although it's a lot of work, a lot of money, and the engineering needs to be pretty precise. But overall, you can just look at it and have a sense of exactly how this roadbed was put together. They carved down the tall spots, filled in the lowest spots, and leveled everything in with this heavy, heavy gravel. You can see the size of these pieces, right next to these ties and these clamps with the nails holding this down. It used to be just these up against here, but they've added more of these in a lot of places. I think these used to be used all the time, but they didn't use as many of them. Now you can see there are lots of them. And that's in different places, different levels of engineering. The freight that comes through here can be all kinds of stuff. Slightly moist corn, fresh off the kernel. Still kind of dry, but with something of a certain standardized water content adds a bit of weight. You got whole bins full of gravel like this for lots of cars sometimes. So on Mars, a rail would be a really good idea. See, the problem is the way the rail came in the United States, there was no right-of-way for people to avoid. They were simply told out, go take the land. Now, in order for Mars to be a real significant place for people to go and not have to deal with a whole bunch of guilt trips of we hurt you or you hurt us over some land, we work out ahead of time how to make this work. And don't call it an ism, it's just a plan for the early survey and demarcation of where to do what on Mars for the whole planet. A single plan doesn't take up too much in resources, really. It's really just a data issue for the moment. But it helps to define landing sites. It helps to define early development and allowing corridors to happen so that you don't have eccentric billionaires spending their money pulling tunnels under LA, which is a great project, by the way, and I'm sure he learned a lot that he can use on Mars. But you take surface rail and you widen the rails. Imagine if you took out these two sets of tracks, you took out the middle two rails, right? And leveled these up and made these a little bit beefier to handle more load. And you spit them out of a mine and foundry right on Mars, somewhere where you survey and you find some, good iron deposits, and you go to work, which shouldn't be too much trouble because we have some really good penetrating data. On the surface chemistry and stuff of Mars. So we've got great stuff to go and attack the problem. How do we get resources once we get there? But rail and dirt road, which, as you see back in that direction, there's a dirt road, and there's rail, and there's even animal trails. So there's a complex transportation environment here. We've also got these culverts that go underneath the rail, and they protect it from damming up and sudden erosion. So the water can just go through there, and that's cool. Everything's cool. By putting up a bunch of gabions and slanting the bottom gabions in just a little bit, you could force it to erode, and as it erodes, your installation of wired together gabions would cover these hillocks here, but leave and the edges of that channel there, but leave the bottom completely exposed, and it would erode much faster, cutting a deeper one, into which you put a pipe, a bunch of sand, and layer gabions right over the top of that, and it's done its work for you. What we got for time here? We got, looks like 7 minutes and 10. So imagine Elon Musk or somebody else lands on Mars in the next 10, 15, 20 years. And they have picked the site because it is close to the center of a big square where there's no right-of-ways. Right? The civil infrastructure will never ask them to give up space for that kind of thing, outside of changing the law specific to a given region. So our lander can go to the middle of such a picked out site, or close to it, geographic middle. And that, of course, would be a good spot to start building the spaceport for your sector. You just land right where you need to be. And you build your own road wherever you want it to go to the right-of-way. And if there's nothing on the ground in the right-of-way, you're allowed to build a roadbed, a simple roadbed. And then later, when you have much more population and you're ready to commit big resources, you can put in transportation heavy infrastructure in those right-of-ways with mixed rail, road, underground, pedestrian underground, an extensive connection into underground facilities, either in natural hollow spaces like canyons or caves, or you simply mine out the rock and make those spaces near these transportation corridors. Because there's a lot of advantage in being underground, and you might as well have a mixed use. Put a bunch of stuff upstairs that if it gets punched, nobody gets hurt. You lose some equipment and you keep going. The foam idea would work well, but I have to describe that in detail. And that's going to be on another video. So I'll do that here in a minute when I've rested just a little bit, and I'll get into space engineering foam.